In this video, I will show the different ways to encode a washout of the system or a selective reset of a model variable. First, a washout can be defined with an event ID column in the dataset. This column can take 5 different integer values from 0 to 4. Among them, the last two values define a washout. The value 0 characterizes a response line, which means that any dose-related information on that line is ignored. The value 1 indicates a dose line, so any response-related information on that line is ignored. With the value 2, both dose and response-related information is ignored. Finally, 3 and 4 correspond to dose lines with a washout applied just before the dose, which means that all the variables of the system are reset to their initial values. In the case of the value 4, an occasion is also created if the dose is not the first. Let's now see an example in Monolix. In this project, each individual receives two doses, at time 0 and 50. There was actually a washout period before the second dose, so a column event ID with the value 3 on the line of the second dose defines a washout just before that dose. We can see on the individual fits that the system is reset to its initial value before the second dose. If this dataset comes from a crossover study, where the two doses given to each individual are two different treatments, the changes in treatments could be taken into account with a categorical covariate for the treatment, such as this column. However, in Monolix, a covariate must stay constant in time for each individual, so it is necessary to define each treatment in a different occasion, such that each subject occasion is characterized with a unique value for the treatment covariate. Here the occasions can be defined with the washout by replacing the values 3 by 4 in the event ID column. This is what has been done in this project. The treatment is now defined as a categorical covariate, and each individual has two occasions, as we can see on the individual fits. The washout is still visible, and it is now possible to explain the variability between subject occasions with a covariate effect of the treatment that can be defined here. So the event ID column has the property to reset all the variables of the system. To apply a selective reset of some compartment rather than a full washout, another method should be used that I am going to show now with another example. A selective reset or emptying is particularly useful to model a concentration in milk or urine. If I want to model a dataset that contains drug concentration in plasma and drug amount in milk, I can use a structural model such as this one. The plasma concentration is described with a simple one-compartment model with an oral absorption and a linear elimination. And an additional compartment is included to model the milk compartment with a transfer from the central compartment. The dosing information is defined with macros in a block pk. The macro depot is used to fill the target variable AC, the amount of drug in the central compartment, with doses of administration ID 1, with an absorption rate. In addition, the fact that the milk compartment is emptied after each measurement is indicated with the macro empty, with the target A milk, the amount in the milk compartment. The times of emptying are defined with pseudo-doses included in the dataset with a different administration ID than the drug doses. Here ADM equals 2. The pseudo-doses are encoded as doses, but they will be used in the structural model as emptying times applied by the macro empty. In this case, the amount of these doses is not used. Note that there also exists a macro reset that works the same way as empty, but it resets the target variable to its initial value, while the macro empty sets it to 0. In conclusion, I have shown several ways to define reset or emptying of some variables of a model in Monolix. Here is a table that sums it up with two main methods. Writing the value 4 or 3 in a column event ID on a dose line automatically applies a washout just after the dose, meaning that all variables of the system are reset to their initial condition without having to define the washout in the structural model. The value 4 can also create separate occasions. Alternatively, pseudodoses can be included in the dataset with specific administration IDs and can be used to define reset or emptying times for specific target variables in the structural model with the macros reset or empty. Note that it is of course possible to use each macro several times to reset several variables, and it is also possible to write target equals all to reset all variables in the system. That's it for this video. See you next week!